All right, next example, example 3. Same type of question as the previous video in example 2. Determine the radius and interval of convergence for this power series. All right, so again, whenever you are asked to do asked a problem that involves the radius or the interval of convergence, it's a good bet that ratio test is what you want to do, but it's not a guarantee, but it's a good place to start. If you see a factorial, then it's really a good bet that ratio test is what you want to do. Sometimes the root test is also applicable, but this would be in a context where everything's being raised to the nth power or the 2n power, or you could at the very least express all or part of your expression as being raised to the nth power, which here that doesn't work. Only this term is. I can't re-express this in any way, shape, or form as something to the nth power naturally. Okay, so again, ratio test, we want to just write down what a sub n and a sub n plus 1 are. So a sub n is n minus 1 factorial x to the n. A sub n plus 1 is n factorial x to the n plus 1. And of course, we're hopefully by now in the habit of immediately just writing this as x to the n x, just splitting that exponential up. So for the ratio test, our ratio rho is the limit as n goes to infinity, the absolute value of a sub n plus 1, which is n factorial x to the n times n, all over a sub n, which is n minus 1 factorial x to the n, absolute value. The x to the n's cancel. Oops, I wrote an n, but this should be an x. My bad. There we go. Okay, now that's fixed. The absolute value will only really continue and carry on to this x term. For the n factorial and the n minus 1 factorial terms are positive. So we will have an absolute value of x, and because this is a limit as n goes to infinity, not x, I am free to pull out or factor out this absolute x outside of the limit. And then I can drop the absolute value bars on the n terms because they are redundant. Furthermore, this n factorial term, I can write n factorial as n times n minus 1 factorial. The reason why we would want to do that is because we really would like to cancel out the factorials. So there we go. So what's left over here is the absolute value of x times the limit as n goes to infinity of n. Well, as n goes to infinity, n goes to infinity. So infinity times the absolute value of x, this is equal to infinity. So this tells us that rho is equal to infinity, which is strictly greater than 1. So this says diverges. What's important here, and slightly counterintuitive, although it's not if you really think about it, but there is this sort of tendency for people who are first seeing this kind of example to misinterpret what's going on here. A lot of times we do find the radius of convergence from this rho. It's directly related to this rho. What's important to keep in mind is while the radius of convergence is related to the value of rho, it is not equal to the value of rho. It's just related to it. In other words, you need rho to figure it out, but there's not a direct equality between the two. So the misconception and the pitfall that's common among Calc 2 students learning this for the first time is when they get this infinity answer, they want to just say that the radius of convergence is infinity, and that's not true. Remember, what does the ratio test say? The ratio test has 3 different possible conclusions you can draw from it. Conclusion 1 is that rho is less than 1, in which case we have absolute convergence. Option 2 is that rho is greater than 1, in which case we just have divergence. Option 3 is when rho is exactly equal to 1, in which case the ratio test is inconclusive. It's not saying... Inconclusive is not saying that the series diverges or converges. It's just saying the ratio test is not a strong enough or appropriate tool to determine what's going on in that case. Okay. So right now, we are in the case where our rho is greater than 1. So this actually says our series diverges. It diverges. Well, there's 2 things to keep in mind. Doesn't matter which one you really... Hopefully you keep both of them in mind. But there's 2 different ways you can explain what happens next. First thing is some facts that we know. Well, so thing number 1 is we have already talked about how every power series, no matter how complicated the coefficients are, every power series converges at its center. Now, if your power series is interesting at all, it would converge at more than just the center. But every power series, at the very least, does converge at its center. So there's always one value where it converges. So the fact that this statement here says that it diverges is seemingly contradictory, because this power series doesn't diverge. It does converge at its center. Here the center is, of course, we can interpret x to the n as x minus 0 to the n, in which case the center is x equals 0. So it does converge at its center. But because rho is infinity, this means that it diverges everywhere else. One thing we could do here is actually kind of move back a step to the step right before we answered the limit. Is there any value of x here? Is there anything you could plug in here for this x that would make this product, absolute x times the answer to our limit, that would make this product not equal to infinity? Yes, you could plug in x equals 0, in which case this would equal 0, which is less than 1, which means converges. So now you might remember from Calc 1 that 0 times infinity is an indeterminate form. That is true when both terms are approaching 0 and infinity respectively. And perhaps you heard my hound dog Jasmine in the background, barking at somebody. So, regathering my thoughts here, you may have heard or remember from Calc 1 that when you have a limit, such as the limit as, let's say, n goes to infinity of, I don't know, let's say, oh dear, what do I want to say here? Let's say 1 over n times the natural log of n. So ln of n over n. Right? We can think of it like this. We could also think of it as 1 over n times the natural log of n. However you want to think about it. I do want to think about it like this, a product of 2 terms. So this term here, natural log of n, it's going to go to infinity. 1 over n is going to go to 0. So together we get the indeterminate form 0 times infinity. So 0 times infinity as this indeterminate form does not equal 0. And the reason for it is these two expressions are not fixed. This is not the fixed number 0. This is an expression that is limiting to 0. And this is an expression that's not equal to infinity. It's limiting to infinity. And because of that, in this limit sense, we can't just do arithmetic in this way because they are both approaching. They're not that actual value. Which contrasts the situation that we have here. This term here is approaching infinity. It is approaching infinity. But this value here is not approaching anything. It's a fixed value. It's just a placeholder. We could have plugged in 0 here, or we could plug in 0 here, or here, or here, or here. At any stage, we could have plugged in 0. And in that case, we would have all of it making sense, and we wouldn't have to deal with this strange kind of 0 times infinity is 0. I thought 0 times infinity was an indeterminate form. Well, if they're both limiting to a value, then you can't just do that arithmetic. But if you consider 0 as a fixed value and infinity as a fixed value, or even leaving infinity in flux as a limiting value, that arithmetic, that product, can be done. So we can think about it like that. So the second thing is exactly what we just talked about, in that this expression equals 0 when x is 0. All right, so we do have the fact that this power series does converge at its center, but because this rho is infinity for any other value other than x equals 0, we're going to get divergence for any value of x we plug in other than 0. So what you end up needing to conclude here is that although rho is equal to infinity, which is greater than 1, this actually means that the radius of convergence is 0. And this is the thing that's counterintuitive. People will see infinity here, and then they're not really trained or inclined to immediately conclude the polar opposite value, go from infinity and then conclude 0. But you really have to think about what this is saying. This is saying that no matter what value of x you plug in other than the center, remember, other than the center, no matter what value you plug in, you will get rho equal to infinity, which means divergence. So if you move, again, think of a number line. Here's the center of our power series. If you move any distance away from the center, you get divergence. Then that means your radius of convergence has to be 0, because that means you're not allowed to move at all. You're not allowed to move away from the center. Any motion, any movement away from the center at all will result in divergence. So the radius of convergence is 0, and because of that, the interval of convergence isn't really an interval at all. It's a it's barely anything at all. It's just the set consisting of the single point at which the series converges, which is the center of the power series, which in this case is 0. We would call this like a degenerate interval. We could express it like this. We could say 0 and 0, but that is not really very well accepted notation. So the radius of convergence is really a degenerate interval. It's not even an interval. It has no width or length. It's just a single point.